Hey y'all. Alright, so what I want to do now is go through some derivative multiple choice problems. These are from the 2012 AP Calc AB exam, the practice test. So we're just going to go through certain ones that I've selected that are just noteworthy or more difficult maybe. Yeah, so let's start. This first one, the reason I want to start with the first one is because it is a chain rule and you need to know how to recognize chain rules. So I'm going to write chain rule. Chain rule you use when there's a function x cubed minus cosine x inside of another function, like something to the fifth. That's your second function. So we have like a quick trick for chain rules that have like two pieces, the inside and the outside. But I also like to teach how to use u and v to define both pieces. So I'm just gonna stick to that method for those of you who like that method. So u is always going to be your inside function. So I'm going to say u equals x cubed minus cosine x. And then v equals, and we're doing chain rule because we're trying to take a derivative, by the way. These are all derivative problems. Yeah. Okay, so u is your inside function always. V is always your u function, and then whatever is happening to that u function on the outside. So u to the fifth in this case. Okay, so now what we do is we take the derivative of both of these pieces. So the derivative of u is 3x squared, and then derivative of cosine x is negative sine x, so it's going to turn into plus sine x. And then derivative of u to the fifth is 5u to the fourth. And you have to plug back in for u. So equals 5, u was x cubed minus cosine x to the fourth. Okay, now that we have both pieces and their derivatives, we need to multiply them. So we're going to say y prime equals this 3x squared plus sine x times this, 5. And then we have x cubed minus cosine x to the fourth. All right. This is our derivative. We need to look for it in our multiple choice answers. So you can see every multiple choice answer has 5 out in front. We have a 5 that could be moved out in front. Now we just need to look for these two pieces in parentheses. So this has 3x squared plus sine x, but these don't have the second piece. So none of these can be right because they don't have this second piece of cosine, or they don't have two set of parentheses. And then we have to be really careful. This has 3x squared plus sine x, but it's to the fourth. We want the x cubed minus cosine x to the fourth, so D is not right. Let's check. X cubed minus cosine x to the fourth, yes. And then 3x squared plus sine x, yes. So E is correct. All right, next problem. I'm going to switch to a different color so that we can kind of differentiate between all of these problems. Let's go with this green. Okay, so here we have y equals x times sine x times sine x. That means if we're taking a derivative, we're going to have to do the product rule. So this one is a product rule. For product rule, the derivative is going to be the derivative of the first function, derivative of x, which is 1, times the second, just copy the second function, plus derivative of the second. Derivative of the second is cosine x times whatever the first is, which is x. Okay, so now we are going to simplify. So we're going to say equals, let's just multiply. We have sine x plus x always goes in front of the cosine. We're looking for sine x plus x cosine x. Boom. B is our answer to that one. Okay, next we have, this says let g be the inverse function of f. So we have an inverse derivative. So we have to remember the rule. Here's the rule, if g of x equals inverse f of x. This says that's true. G is the inverse of f. Okay, so if g of x is the inverse of f, then we have g prime of x, the derivative of g, equals 1 over f prime of f inverse of x. This is the rule. Anytime you have an inverse happening, you're probably going to have to use this rule. So now let's look at like what we're trying to find. It says given that f of 0 equals 1. Okay, we know we're dealing with inverses. So let's like go ahead and flip this. F inverse of 1 then has to equal 0. That's like what inverses do. They flip the x and the y. Okay, what is the value of g prime of 1? We're trying to find g prime of 1. So let's plug that in. G prime of 1 equals, we're going to plug 1 into x. So we have 1 over f prime f inverse of 1. All right, we can now work our way from the inside out. F inverse of 1 equals 0. So let's plug in 0 for that. So g prime of 1 equals 1 over f prime of 0. Cool. F prime, we can find that over here. Let's take the derivative of f with respect to x. So I'm going to do that down here. F prime of x equals, we have another chain rule. I'm going to do the quick way now that I've already like broken it down with u and v. So you do the derivative of the inside, 2, and then times derivative of the outside, we would bring out the 3, bring that down, leave the inside the same, 2x plus 1, and then we subtract 1 from our exponent, so we get 2. We need to find f prime of 0. So let's go ahead and plug in 0 here. We get 6, because 2 times 3 is 6. And then 2, 0 plus 1 squared equals 6 times 2 times 0 is 0 plus 1 is 1. 1 squared is 1. So f prime, let's do f prime of 0 equals 6. So we get our answer, our final answer is 1 over 6. D. Cool. We are going to skip number 4 because it's not super difficult. And yeah, it's just not super difficult. You just need to know your derivative rules. Let's go to number 5. So for number 5, 4, the answer is E. For number 5, let's see. Okay, we have f, we have g, and we're trying to find the derivative of f of g of x at x equals 3. Anytime it says like find the derivative of f of g of x, I would just like find the derivative of this with function notation first. So let's say the derivative of f of g of x, we have to use chain rule. So I'm going to write chain rule. And we're going to do the derivative u is g of x, the inside. And then v equals f of u. U is the inside function, v is the outside function of u. Let's take those derivatives now, and then we'll multiply them for the chain rule. So derivative of x is g prime of x. Derivative of f of u is f prime of u. But remember, we have to plug back in for u. U is g of x. So we have f prime of g of x. Let's multiply those together now. So we could say like dx of f of g of x equals, this is the derivative of this thing, equals g prime of x times f prime of g of x. Okay, we're trying to find the derivative at x equals 3. So now I'm going to plug in 3 equals, so I'm trying to like at x equals 3. This is not mathematically precise, but I'm just trying to save some room and time. Equals g prime of 3 times f prime of g of 3. Okay, let's see if we can like now find these two things, g prime of 3 and g of 3. G of 3 should be really, really easy. You just plug in 3 to your g function. 3 times 3, 9, minus 2 is 7. So this turns into f prime of 7. Now we need g prime of 3. What is the derivative of g? 3. So g prime of 3 is just 3. Okay, So that means that we have 3 here times f prime of 7. That's what we're trying to find. Okay, we need to find f prime. So let's go over here. This is kind of a longer problem, but it's worth it because we can do it. Okay, so f prime of x equals, first I'm going to like rewrite this. F of x is x squared minus 4 to the 1/2. So f prime of x is the derivative of the inside, 2x, times the derivative of the outside, 1/2. Leave the inside the same, x squared minus 4. And then remember to subtract 1. We get negative 1/2 in our exponent. All right, we need f prime of 7 though. So let's plug in 7. F prime of 7 equals 2. Oh wait, really quick. These 2's end up canceling out. So this is just 7 times 1, which is 7 on the outside. 7 times 1 over, we have 7 squared. 7 squared is 49 minus 4, 45. And then this turns into a root, so we have square root of 45 equals 7 over, let's simplify this. This is square root, actually, let's just leave it for now. Square root of 45. Okay, so let's bring this over. This is f prime of 7. Let's plug it in. So we get 3 times 7 over square root of 45, which equals 21 over square root of 45. Now, earlier I said let's simplify because I can see there's no square root of 45 over here in the denominator. So that means they simplified. So we need to simplify 21 over square root of 45. I'm going to like bring that here and do that over here. So 21 over square root of 45 is the same as 21 over square root of 9 times square root of 5, which equals square root of 9 is 3. 21 divided by 3, we have 7 over square root of 5. That's our answer, our most simplified form. A. All right, moving on. Number 6. Number 6, we have arctan. Arctan just means inverse tangent. So I'm going to write it how I like to see it and think about it. I'm going to like actually write tan negative 1, inverse tan. So y equals tan negative 1 of x over 3. Cool. This says find an equation for the tangent line. So we're going to need to write an equation for the tangent line at the origin. So your point, we need 2 things for a tangent line. We need a point and a slope, but at the origin means our point is 0, 0. Okay, let's work on finding slope. Slope means we have to take the derivative of this thing. So we're going to do that over here. Let's see. Actually, I'll just do it right here. So y prime equals, this is another chain rule. Your inside is x over 3. So I'm going to break that down actually over here because I wanted y'all to see that. Let's do it down here actually. So we have tan inverse tan of x over 3. U is your inside function, x over 3. A lot of students forget that this can be rewritten as 1/3 x. That's the same thing. V is inverse tan of u. So now we take derivatives. Derivative of 1/3 x is just the constant, 1/3. Derivative of inverse tan is 1 over 1 plus u squared. Remember to plug back in for u. So we get 1 over 1 plus x over 3 squared. Okay, so now let's put these together to write y prime. Y prime equals 1/3 times 1 over, I'll do the 1 over in a second, 1 plus x over 3 squared, all under 1. Cool. We want the slope, though, at x equals 0. So, like, we're going to plug in x equals 0. Y prime of 0 equals 1/3 times x equals 0 is going to make this whole thing go to 0. 0 squared is 0. So this is times 1 over 1. That just equals 1/3. Cool. So this is your slope. M is 1/3. Let's write our equation of a tangent line now. So we have y. I'm going to do the equation. I know this is like not a lot of space. I'm going to do the equation of the tangent line over here. So we have y minus y1 is 0 equals the slope 1/3. X minus x1 is 0. We need to simplify. Our answer choices do not look like this at all. So let's simplify. We have y equals 1/3 x. All right, and again, our answer choices don't look like this. They're just trying to make it extra tricky. It's just some algebra that we have to do. Let's look at what they look like. They all have equals 0. So one side of the equation needs to equal 0. So we have two options. Actually, first of all, we also don't see 1/3 showing up anywhere. So if we don't see 1/3 showing up, we see 3 though. That's a hint that like we need to multiply this 3 on both sides. So let's do times 3 times 3. You get 3y equals x. Okay, now we need to talk about our two options. To get it to equal 0 on one side, we can either subtract x. So one of our answers would be 3y minus x. So I'll like break down our two options. We either have 3y minus x equals 0. We subtracted x on both sides. Or you can subtract 3y on both sides. So you get 0 equals x minus 3y. All right, and now we need to look for, these are both like the same statement. They're just like flipped. 0's on the left side here, 0's on the right side here. It looks like they went with this one. X minus 3y equals 0. X minus 3y equals 0. They moved the equal sign to over here and wrote 0. It means the same thing. Okay. Moving on. Number 7. Oh, this one looks confusing. More confusing than it is. So let's talk about this one. If y equals u plus 2e to the u, and u equals 1 plus natural log of x, find dy dx when x is 1 over e. This just like is stressful. It looks very stressful, but we'll break it down to make it easier. First of all, you have a function of u. They told you what u is. So let's plug into that function. So let's say instead of y equals u plus 2e to the u, we're going to plug this in for u. So y equals, u is 1 plus natural log of x plus 2e to the u, which is 1 plus natural log of x. Cool. We're trying to find the derivative of y with respect to x. So let's do y prime. Y prime equals, derivative of 1 is 0. Derivative of natural log of x is 1 over x plus, all right, constant stays out in front, 2 times, we have to do the derivative of, this is a chain rule, derivative of the exponent, that's 0 plus 1 over x, which is just 1 over x. And then e to your exponent stays the same. All right, here's our derivative function. Now, let's see what else they gave us. X equals 1 over e. So let's plug that in. So we have y prime at 1 over e equals 1 over e plus 2 times 1 over e plus, times e to the 1 plus natural log of 1 over e. Cool. This is looking crazy, but we're going to make it easy. 1 over a fraction will always cause the fraction to flip. This is going to come up into the numerator, the e. You could multiply by the reciprocal if you wanted to, but I just like know this trick. So e comes up to the top. It's e over 1, which is just e. So equals e plus, same thing here, e over 1. So we have 2 times e times, okay, we have e to the 1 plus natural log of 1 over e. All right, remember, this is your base for natural log, e. And natural logs and logs are exponents. It's asking you, like, what exponent do you need to get to here? So what exponent on e would get you to 1 over e? That exponent is -1. So this whole thing equals -1. So I'm just going to put -1 here. So then we have e plus 2e times e to the 0. E to the 0 is 1. Cool. This is e plus 2e, which equals 3e. And your answer is C. Yay. Okay, we're going to skip number 8 and go to number 9. The answer to number 8 is C. Number 9. Here we go. So number 9, a lot of students get tripped up because they don't rewrite. They don't rewrite this in a way to make the chain rule piece obvious. So the first thing we're going to do is rewrite this. Y equals cosine squared x is the same as cosine of x squared minus sine of x squared. So I just wanted to like make sure everyone knew that's how you should start this problem. Rewrite it like this. Then we have a chain rule. So y prime equals derivative of the inside first. I'm just going to be using the chain rule trick. So derivative of the inside is negative sine of x times, you're going to take the derivative outside, so that's 2, and then leave the inside the same, cosine x. Subtract 1 from your exponent to the 1. Minus derivative of the inside first, cosine of x is the derivative of sine. Then you're going to do the derivative of the outside, so times 2, and leave the inside the same, sine x. And again, 2 minus 1 is 1, so that exponent turns into 1. Now let's simplify. So we have negative 2 sine x cosine x right here, minus the 2 goes out in front again. I'm going to put sine x in front, sine x cosine x. Okay, just like we combine the e's here, e plus 2e is 3e. This is like, these are matching terms. They're like terms, so we can combine them. Negative 2 minus 2, that's negative 4. So your answer is negative 4 sine x cosine x. And then we look for that in our answer choices. Boom. E. Cool. All right, we only have a few more. Yeah. Okay. Number 10. I want to do number 10. This one should be very fast. We should recognize that this looks like the limit definition of a derivative. So really quick to remember, limit definition of derivative. The one that I'm talking about is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, that's what we're looking at here. So all this means is take a derivative. This means take a derivative. You have to figure out what is the function we're taking the derivative of. What is f of x? So you're going to look here for that. This is f of x. F of x equals cosine of x. Sometimes they'll give you a number that they plugged in here. So you would say at x equals whatever that number is. But this one is just x. So like we just need to take a derivative of cosine. That's it. F prime of x equals negative sine x. That's it. That's your answer. Done. Okay. Number 11, the answer is B. I'm not going to do that one because we already did an inverse tan. It is a chain rule though, so make sure you recognize that. Number 12. Actually, yeah, let's do number 12. Okay. We have a crazy looking function. We're trying to find the equation of the tangent line at x equals negative 1. So first, we need two things for the equation of a tangent line. We need a point and a slope. All right, for the point, we know x is negative 1. Negative 1. How do we find the y value when we have the x value? Plug into your original function. So you're going to do f of negative 1. You're going to plug in here. So we have 2 to the negative 1 squared minus negative 1 minus 1. That would be your y value. Let's simplify it so it actually looks like a point. We have the point negative 1, comma. All right, negative 1 squared is 1, plus 1 is 2, minus 1 goes back to 1. So we have 2 to the 1, which is just 2. Cool. Let's find the slope now. Slope is derivative in calculus, so let's first do f prime of x. This is a chain rule, so should I? Yeah, let me go over it. This one's kind of crazy. So we'll do u. That's the inside function. That's going to be your exponent. U is x squared minus x minus 1, and v is 2 to the u. All right, derivative of each piece. This derivative is 2x minus 1. Derivative of 2 to the u is natural log of 2 times 2 to the u. but we have to plug back in for u. Remember, u is this thing. So this turns into equals natural log of 2 times 2 to the u was x squared minus x minus 1. All right, let's multiply those two together. So like this guy and this guy are going to multiply to get our slope, or our derivative function. So we have 2x minus 1 times natural log of 2 times 2 to the x squared minus x minus 1. Sweet. All right, that's our derivative function. We want the derivative at -1. F prime at -1 equals, I'll just write it out. I was trying to be lazy, but I won't be lazy. All right, so we're plugging in -1 for all of our x's. -1 squared minus -1 minus 1. All right, 2 times -1 is -2, minus 1 is -3, so we have -3 times natural log of 2 times 2 to the, remember we already did this thing over here. That turns into 1, so 2 to the 1. So we get, this is multiplication, so like your coefficients or your constants can just go all the way in front and multiply. So this turns into -6, 2 times -3 times natural log of 2. All right, this is our slope. M equals, now let's finally write our equation for our tangent line. Y minus y1 is 2 equals, this is our equation for our tangent line. Y minus 2 equals slope, -6 natural log of 2 times x minus x1, but that's negative, so it's going to actually turn into x plus 1. All right, if we look at our answer choices, y is isolated in all of them, so we need to add over the 2. Y equals -6 natural log of 2 x plus 1 plus 2. Now let's look at our answer choices. This one has -6 natural log of 2 in it. So let's just check that it has all the other pieces. Y equals -6 natural log of 2, x plus 1 plus 2. D is your answer. Okay, one more problem. I'm not going to do 13. The answer to number 13 is A. You do need to know one important thing for number 13. You need to know the inverse sign. We need to know how to do chain rules. But you also need to know that the inverse sign derivative is 1 over the square root of 1 minus x squared. So just be aware of that. Okay, let's do 14. 14 is a little bit more complicated of a chain rule. First thing we're going to do is rewrite g of x. So g of x equals, anytime I have like a trig function squared, I like to rewrite it to have like the square on the outside of the whole thing. So we have g of x equals tan of e to the x. That whole thing is being squared. Okay, to take the derivative to find g prime, we're trying to find g prime, you're going to break into pieces because it's a chain rule. U equals your very most inside function, e to the x. V equals tangent of that function that we called u, so tangent of u. And then w, in this case we have 3 pieces. W is v, that's the tangent function of e to the x squared. Cool. And then chain rule means after we break it into our parts, we can just take the derivative of each part, which we're going to do over here, and then multiply all those derivatives together. So the derivative of e to the x is e to the x. Derivative of tangent of u is secant squared of u, and then the derivative of v squared is 2v. We need to make sure that we plug in for u and v. So u was e to the x, so we're going to say secant squared e to the x. And then v was tangent of u, so let me plug that part in first. But we know u is e to the x, so now we're going to say this equals 2 tan e to the x. Okay, we have our 3 derivative pieces. So now we just multiply them together. G prime of x equals e to the x. I always like to have the 2, like if there's like a constant, I'll put it in the very front. So I'm going to put that 2e to the x in the front. And then let's copy these. We have secant squared e to the x tan e to the x. Sweet. Let's look for our answer choices. So we have 2e to the x. This one doesn't have 2e to the x, so we should be looking at this one and this one. This one's missing the secant squared part. Does this have everything? 2e to the x, yes. Secant squared e to the x, yes, and tan e to the x. A is the correct answer. All right, that's all the derivative practice multiple choice that I'm going to go over. Eventually, I'll go over a free response question related to derivative rules. But until then, goodbye. Bye, y'all.